Hello, and welcome to my presentation on interpolation search. Next slide, please. Say you have a set of data numerically distributed like this, with 1, 3, 4, 6, 7, and 9 from top to bottom in value. It's going to use a probe to determine the position of the data you want. Let's say you want 3, that's going to be your probe in this data set. This is the formula that it uses. Probe is equal to low end plus high end minus low end times the item minus data low end divided by the data high end minus data low end. I'll explain that more in a little bit, but this is the basic formula you're going to have. And another thing to remember is in computer science, you always want to use zero-base indexing. So the start of your array is always 0, and the end is the number of data points minus 1. So this would be 0 in the data set, 1, 2, 3, 4, and 5, which there's 6 of them, so it's 6 minus 1. Next slide. Why do you want to use an interpolation search? It's a very efficient way to search through data, and it takes very little steps to find the data you need. It actually adapts to skip unnecessary data points, usually leading to a faster answer. It can be slower, but there are definitely very good reasons why you should use an interpolation search in certain situations. But there's also reasons not to use it. Everything has to be uniform in your data set. You can't have doubles, or at least it won't show multiple data points. You have to have a data set of, or let's say you have a data set of 1, 2, 2, 3, 4, 5, and you want to find 2. It will only find one of the 2s. It will be the first one it comes across. So it won't show both the 2 points in the data set. It's very complex, and it can slow down your performance because of the fact that there's so many things you have to go through for an interpolation search. And the data has to be sorted. You can't have 1, 9, 2, 3, 5, 4. It can lead the program to be unable to find the answer that you want. So it's kind of the problem of like it needs to be able to see the difference between the top and bottom. It's a big problem in interpolation search. There are a lot better searches that will find your data better in these kind of scenarios. Next slide. All right, for this, I have a little chart, and this is the formula we're going to be using. But as you can see on the chart, it has this data set 1, 3, 4, 6, 7, 9. So the first thing it's going to do is find the low end and the high end, which is the low end is 1 and the high end is 9. Those are the 2 data points that we're going to be using for part of the set of data. So let's say you want to find 7 in the data. So the probe would be at 7. So let's put probe. Our probe is going to be right here. Actually, no. We need to take that out. That's my bad. Sorry. Let's say you want to find 7 in the data. It would take the difference between position 0 and position 5, which this is position 0, this is position 5, and we would use the calculation of position equals the low end, or the low index, which is this, the actual position in the data, plus 7 minus 1, so the probe minus the low end data point, times the high end position minus the low end position, and then we divide it by the high data set point and the low data set point, which equals 3.5. So the probe would end up right here. Now it's going to see that the position is 6. So what it's going to do is it's going to move this up to here. So now you're going to have to do the formula, or it's going to move. Sorry, it's going to move here. Because it's going to see that this is wrong. I'm so dumb. I'm so sorry. It's going to see that this is wrong, and it's going to take this data point plus 1. And that's going to be how your formula starts. I actually have this set up wrong. It's going to be 7 plus 7 minus 6 or 7 minus 7 times 5 minus 4 divided by 9 minus 1, which is going to equal 4, and it's going to be this position. And then that's how your probe finds the data point that you're looking for. I used another example of this with multiple sets of numbers. Let's try with this set. We're going to look for 5. So we're going to use the formula. It's going to end up at 4. So it's going to look for position 4, or position 4. It's going to see that it's 5. Or it's going to see that it equals. Why did I do that wrong? I'm sorry, I did that wrong. But essentially, it's going to find the data point immediately using this. But there are data sets, if like I took out the 2, it would probably gone to 4, and then it would have searched higher. There are data sets where, like, let's say I would take out the 8 and a 7, and it would have probably put to 6, and then in that example, it would have been too high, so the data set would have been put to this minus 1 and check the left side of the data pool. It's interesting how it goes from the left to the right, but that's the formula that it uses to do this. So let's look at the actual program. First, you're going to set up your method that's going to create an array in an integer x as an input for the probe and return the placement value for the index as x. So essentially, it's going to create a key that is you're going to use as your probe. It's going to create the array and the key here. Then you want to create the low and the high end of your array, which is going to be the low end is going to be 0, and the high is going to be the array length minus 1. This is the algorithm to find your probe value. This is essentially setting it up so, let's say, it's going to make sure that your probe is not lower than your low or higher than your high points of the array. It's essentially just making sure that it doesn't go too high, and then this is the actual formula itself right here. This is the line that will be our final product, and will be the position of the probe. That's going to be where the position of x is. That's your if, and you have a while loop, or while loop, and so this is going to continue the search if the position is less than x, and so this is going to help it. So with the example of the first example I had, or the last example I had, where I said, like, we take out a number and it's going to go too far to the right, it's going to search the left. That's what oh no, that's what this one does. I'm sorry. This is the searches to the left. This one searches the right. This is the normal one for the first and second example, or the first example we had that I showed you of what it's going to do to search the data more to find your probe's correct position. And this one is going to search the left to find the correct position, like in the example I kind of made up at the end there of Interpolation Search 2. This is in case your variable is not within, or it cannot find your variable within the array. It is going to return a -1. That is very important to a little bit later, but it's going to return a -1 value. Our main method is here. This is the array list we're going to have. This is going to be the position of the variable when found, and if not, it will, again, will show a -1. But this is like this is going to hold the position of the variable, and this is the condition that happens if not -1. It's going to show the index result here. It's a result not equal to -1, found at index plus result. And this is going to be the condition it finds if it is -1, and it's going to show not found. So it's a pretty simple program, but let's say you wanted to add a scanner. I made one that added a scanner. just to show that off, you're going to import Java Utility Scanner. You're going to add scanner, new scanner, and you're going to make a print line, and then you're going to make a scanner key instead of this. It's essentially replacing this right here, which is the value you're trying to find within. Let me show you how it'll do it. So this is, let's say you want to have one that isn't in the array. I'm putting X as 10. So down here it's going to show not found. Let's say you want position 4. Found at index 3. 0, 1, 2, 3. Okay? So with the scanner one, we're going to execute. And it's going to say enter the number you want to find. I'm going to put, I want to find 5. It takes a second. It's found at index 4. 0, 1, 2, 3, 4. Let's try, hold on, number 8. Found at index number 7. 0, 1, 2, 3, 4, 5, 6, 7. So, yes, you have your index key and all that. This is a very basic way to use an interpolation search. It's very good for data sets that are, information is very good for data sets that are uniform, that have a clear set of data that is, I forget the word, that is sorted. As long as you have a data that is sorted and uniform, so it's all different numbers, you will be able to find your data really easy, usually at less steps, making your program run faster. But there are problems with it. But I hope you have enjoyed my presentation. Thank you very much.